In this video, we're going to do some examples of dissociation equations for bases. So the rules are very similar to ionization equations for acids. So if you have a base with OH, you're going to write the formula with S if it's strong or AQ if it's weak. For a weak base, you're going to put a double arrow. For a strong base, you're going to put a single arrow, similar to strong bases, weak acids. And then you're going to write the products as the dissociated aqueous ions of OH minus, and then the cation that's left over from that. So let's take a look at two examples here, sodium hydroxide and barium hydroxide. You'll notice that sodium hydroxide and barium hydroxide are both strong bases. So let's go to our handout here. So for sodium hydroxide, we're going to write it out as a solid because it's a strong base. So we're going to have NaOH, solid. Single arrow becomes the ion, the cation Na plus in water, aqueous, plus OH minus in water as well, aqueous. We can write this the long way. You can do NaOH, solid, plus some H2O liquid, and then it'll become some dissolved sodium ion, and then your hydroxide ion like it was before. And then for barium hydroxide, very similar situation, but it's a little bit different because notice that we have barium OH 2. So there's two OHs there, solid. And so in that, it's going to be one arrow because it's a strong base. We're going to have Ba plus 2 AQ plus OH minus AQ. But we do want to make sure it's balanced, so you'd put a 2 in the front there, like that. And so that's how you go about writing your dissociation equation for barium hydroxide. Again, you could write them the longer way, but typically it's okay to write it this shorthand way. It works out just fine. It illustrates the same concept, especially because you have AQ there. And you'll notice that a lot of calculations you'll do in grade 12 end up using the shorthand method anyways, because oftentimes in our calculations we'll omit water when we're doing fancier calculations with weak acids, strong acids, weak bases, and strong bases. We focus really on the OH part than the H3O plus part instead. So now you'll be able to write ionization equations for acids and dissociation equations for bases. And you also know the differences between the different theories of acids and bases, and also what it means to be a strong acid versus a weak acid, and a strong base versus a weak base. So for homework, you can practice the problems from the learning goals. The learning goals can be found in your unit calendar here. And when you open up the learning goals, you'll go straight down to the acids bases lesson. There's a few different acid bases lesson. The one that we just went over is called the properties of acids and bases, and you have some worksheets here to go over that. One more lesson that we'll go over for introduction of acids and bases is pH calculation. So most of you are familiar with what pH is and the pH scale is and what defines an acid and base based on that pH scale. But now we're going to see how do we get that number using concentrations of H plus and OH minus.